Okay, so this is my first video on my sequencing calculus, and this is for section 1.1 out of the textbook, and you can go to my website to get more information about this. And so to start off with, I want to go through, here's basically my suggested homework problems out of this section, 5, 9, 12, 16, 17, 19, 20. You can just download the handout and get that. So the first thing that I want to go over is this lecture is about key points. And so one key point is functions. And so what is a function? Okay, so a function is a transformation or relationship between a set of inputs and a set of outputs, with an important point. And the point is that this is super important. Every allowed input must have just one, exactly one, that's critical. Every allowed input must have exactly one output. So if we look at a couple of example functions, the simplest example function, and we're going to start to talk about this in a little bit, is if you've got y equals mx plus b, and so sort of you've got some line here, and so if I look, that's the point roughly 2, 4. That's the point roughly 0. Let's call it 7/3. And that's roughly the point, call that 5, 5, 6. Okay, so I've got a whole set of inputs, and then here's my outputs. And so if I look more specifically, I've got 0 gets transformed into 7/3, roughly just looking at my sketch. 2 gets transformed into 4, 5 gets transformed into 6. And, I'm probably going to, let's probably fix that in a little bit. And let's use these 2 points here to figure out what y equals mx plus b is. Well, m is the slope, and this is going to factor really, really, really critically in our understanding of calculus. So slopes are critical to our understanding of calculus. And so that's going to be change in y over change in x, or it's going to be y2 minus y1 over x2 minus x1. And so continuing along, I'm going to have 6 minus 4 over 5 minus 2. And so that's going to be 2 over 3. And so my slope is 2/3. Okay, just reviewing really quickly. And so then if I want to find b, I say that y equals 2/3 x plus b. Well, let's just plug in the information that I have. Let's plug in all the information that I have. Choose a point. I don't care which point. We're going to, not that one because we're going to fix that one. Let's choose 2, 4. So my y is 4. Then my slope is 2/3. My x is 2. And then I've got plus b. And so that leaves me with 4 equals 4/3 plus b. And that leaves me with b is equal to, well, that's going to be 8/3. And what did I say that it was over there? I said it was 7/3. So I was off by 1/3. So then finally, for that function, I've got y equals 2/3 x plus 8/3. And that is my function. So here's my inputs, and then I run it through a transformation, and then I get my outputs. And as long as I'm here and dealing with this, we can also, so this is going to be called slope-intercept form, because right here is my slope, and right here is my y-intercept. But I could also write this in point slope form, and my point slope form could have, well, let me just write out the general form. The general form is going to be y minus y1 equals m times x minus x1. And then I could have a whole bunch of different values for that. I could have y minus 4 equals 2/3 x minus 2. That would be one possible form. I could have y minus 6 equals 2/3 x minus 5. Or I could have y minus 8/3 equals 2/3 x minus 0. And you could figure out that you could transform these into each other, and you could all transform them up into the slope-intercept form. Okay. So the next thing that we need to sort of talk about is a domain and range. And so we're going to say domain is the set of all inputs that generate a valid output. And for the range, I'm going to call that the set of all outputs generated by the domain. So the domain is so basically you put numbers in and you get numbers out. And by valid in this case, for what we're going to talk about, valid means real numbers. That's just the definition that I'm going to come up. Valid means real numbers. Okay, so if I've got y equals 2/3 x plus 8/3, I can put any x that I want into this and I can generate a y. Any real x, any real x will generate a real y. So my domain is going to be, we're going to call that, let's do it this way. We're going to say -infinity to infinity, or we could say x equals, where that stands for the set of all real numbers. Or I could say -infinity is less than x is less than infinity. Okay, and so then my range is going to be all the possible outputs that I can get from these inputs. And for a linear function such as this, it's pretty simple. It's basically the exact same. I can get any y that I want as long as it's real by some choice of a real number that I put in. And okay, so let's look at a couple of functions that have a restricted range. So the most obvious one is y equals the square root of x. And so that, if I plug in a negative number, I can't get a real y out of that. I can't take the square root of a negative number and get a real y. So my domain is going to be 0 to infinity. And now, so this, the square bracket, means that my domain includes a 0, and the round bracket, the parentheses, means that it's up to but not including infinity. And we always have to put that up to but not including infinity because infinity is not an actual finite number, and so you can't include infinity. It's just kind of the way it is. Or we can say that it's 0 less than or equal to x is less than infinity. And my range is going to be basically the same. If I plug in 0, I get 0. If I plug in something close to infinity, I get something close to infinity. Okay, there's one function. Let me give you another function. Let me give you two more functions here. Y equals sine x, and then we'll do y equals 1 over x plus 3. Okay, so for y equals sine x, I can plug in any number that I want, and I can get I can get a valid real output. I can plug in any real x and I can get out a y. But, as you should know, my range is really restricted. It goes from -1 to 1. Oh, and it's inclusive. It includes those. So, the sine of pi over 2 is equal to 1. The sine of 3 pi over 2 is equal to -1. The sine of 5 pi over 2 is equal to 1. The sine of 7 pi over 2 is equal to -1. And I can't ever get above, the sine function never gives me an output that's greater than 1 or less than -1. Okay, let's look at this one. My domain is going to be, we could say x cannot equal -3. Well, sorry, x cannot equal -3. Or we could write this as -∞, comma 3, union with 3, comma infinity, where 3 is in my round brackets because it's not included. And so, because if I plug in 3, I get undefined. Now, my range, there's only one range that there's only one number that I can't get from this function as an output. And you sort of think about it and you go, well, 5,000, no, 3, no. Okay, the number that I can't get with this function is 0. There is no number that I can plug in here to get precisely exactly equal to 0. So, and I'll let you think about that for a little bit. So my range that's going to be my range. Okay. Let me label that. So the next thing that I want to do is I want to talk about sort of, again, functions and vertical line test. And so, the vertical line test is basically, if I take some function, if I just take sort of any arbitrary function here, any vertical line that I pass through this function meets the function at exactly one point. And so if I go back and I look at this, every allowed input must have exactly one output. That's critical to the definition of a function. So here, this is a function of x. Every allowed x generates exactly one y, or every allowed input generates exactly one output. Okay, but if I sort of take that same function, let's make that a dotted line. Okay, so this is not a function of y, and it's not a function of y because some values of y generate more than one x. Some values of y generate more than one x, which is not allowed under the definition of a function. Okay, so we have some functions that are functions of x, we have some functions that are functions of y, we have some functions that are functions of x and they are functions of y, and you just sort of have to look at the horizontal line test and the vertical line test. Okay, but then you have some functions, so that's going to be x squared plus y squared equals, say, 4 or 16. So this has some this does not pass the vertical line test and it doesn't pass the horizontal line test, but nevertheless it's a very common thing, and so we don't want to kind of throw it out totally. So we will come back and we'll sort of talk about that a little bit at some point in time. And then I guess the last thing that I want to say to wrap up this lecture is we want to talk about direct functions that are directly proportional, and functions that are inversely proportional. And so we're going to write that as y equals kx, but we could also write that confusingly as k equals y divided by x. And then inversely proportional, we can write that as y equals k over x, or we can write it as k equals xy. Okay, so you guys sort of get those straight. And the way that I think about it is okay, as x goes up, y goes up. That's directly proportional. If it's one of these two things, there's other ways. This is just kind of rough. That's not a straight definition. But as x goes up, y goes up with a constant of variation, or basically this says the same thing here. As x goes up, in order for k to be a constant, y has to go down by the same proportion. Oh, I guess I got one more thing that I want to say. So if I say a good example would be F equals kx, and so it's the force of a spring. Let's make that negative. Okay, the force of a spring is equal to a constant times the distance stretched. Okay, so then we've got F is some function of x. And so if we say F of 0.5 is equal to 7, what that means is that if the force is stretched 0.5 meters, the force is 7 newtons. So I sort of go through and I do this. This is my input and this is my output. Input, output. Okay, I think that's all I got to say for this section.